Thanks, Michelle. Okay, area between two curves. So we found our area underneath a curve last class, which was pretty cool because you could have like a sine curve moved up and you could figure out the area underneath the curve from there to there. But now we can have some fun with that and say perhaps we had a parabola like this. Could we find this area, coloring crayon, blue, no, brown. Could we find this area in between those two curves? Ooh, yes. Maybe we could even find, kind of looks like a backwards Nike symbol almost. You can make like a Nike symbol thing with two curves and then figure out the area of that Nike symbol if you wanted to. How do you find that area between those two curves? You just do it. Nice. Oh, you're waiting for that. Well, you're going to need to find these points. And those would be the points where those two curves intersect. Then, if you just use the concept we had from before, if I draw a line down from there to there, take out my crayon, and keeping with the color, if I colored this whole thing in brown, can you see that that brown thing would just be the area underneath my sine curve? Then if I took out a black one and just did underneath the green one, that would be the area under my parabola. So how do I get my area in between the two curves? You just have to take the one area and subtract the other area, and then you get areas of crazy shapes that aren't nice on any sides whatsoever. So that's what it is saying right here. If you want to find the area between those two curves,
with the last names A to N, please report the cafeteria for report cards. Grade 11s, A to N, please report to the cafeteria for your report cards. Thank you.
so all you need to do to find that area between the two curves is take the area of the upper curve, subtract the area of the lower curve, and you'll get the area in between those two curves. So here we have two parabolas, x squared plus 2x plus 2 and negative x squared plus 2x plus 10. I'm going to draw a sketch of these ones just quickly without any axes. I'm going to do that one in blue, this one in green. Would you agree that that blue parabola looks something like this? We don't know how wide or how narrow, or, well, we could say some things about the width and how narrow it is, but the most important thing from that is that it is going up. And our green one, it's going down. So when we want to find the area between those two curves, a couple of things are going to be important. We're going to need to find these 2 points of where they intersect. And when we set up our integral, if I call my green one g of x and my blue one f of x, when we set up our integral, can you see that we're going to have to do g of x minus f of x? One of the things your sketch is going to tell you is which is the function that's above the other function. And since the green parabola is going down and the blue parabola is going up, if they do intersect, it has to make sense that the green one's going to be on top. I mean, we have an option that it could be that this green parabola is down here and they never intersect. But then there would be no area between those two curves. So if they do intersect, then we would have this one, the green one, on top and the blue one on the bottom. Well, how do we find out when they intersect? We take our two equations and we can equate them. If they intersect, we have two equations with two unknowns. We could solve that. I would use substitution. X squared plus 2x plus 2. Well, that's equal to y, so I substitute it into the y for the other equation. It's a quadratic equation. We set one side equal to 0. 2x squared minus 8 equals 0. Just because there's just an x squared, you could factor this, or you could move the 8 over, divide by 2, square root both sides, and get x is equal to plus or minus 2. So now that I know that, I could add some axes to my drawing. Okay? I know that it intersects at minus 2 and at positive 2 for those 2 points. I don't know how high or how low those parabolas are. I don't know that they're both above the x-axis as I've drawn them. I mean, you could take the time to find your vertices and graph these more accurately. But the nice thing about the area between the two curves, unlike when we did the area between a curve and the x-axis, remember we had to find all the x-intercepts and worry about some areas being negative and some areas being positive? And that was a little bit of work, but you got rewarded because you got to color. But this one, it won't matter if this axis is here, here, wherever it is. You just have to do the integral of one minus the other one, and all the negatives and positives will always work each other out, and you'll get the area between the two curves. So that's kind of nice. You don't have to worry about some part being below and some part being above. So now that we've found that we want to have it between negative 2 and 2, we can set up our integral. Our area is going to be the definite integral from negative 2 to 2. And here, since the green function g of x was on top, we would do g of x minus the blue function f of x. Now, I know that at the beginning here it says you can do the integral of each one separately. You still could do that if you wanted to. But in this case, you're going to find out if I plug in what g of x is. So it's going to equal the integral from negative 2 to 2. And g of x was negative. There we go. X squared plus 2x plus 10. And f of x was x squared plus 2x plus 2. If you combine your like terms, your life is going to get easier. This just simplifies negative x squared minus another x squared, negative 2x squared. 2x minus 2x is 0, and 10 minus 2 is plus 8. And if you simplify it, you're going to have less things you have to integrate, which makes your life easier. So now we can integrate this fundamental theorem, put our 2 and our negative 2 there. This will be negative 2x cubed divided by 3 plus 8x. Plug in our top value, negative 16 over 3 plus 16. Plug in our bottom value, 16 over 3 minus 16. Again, when working with this, I'd probably combine my like terms. Negative 16 over 3 minus 16 over 3, that'll be negative 32 over 3. 16 plus 16 will be plus 32. Get a common denominator. Yeah, I'll go up. Is that good? I'll wait a second. If we get our common denominator, We get positive 64 over 3. So that's going to be our area. If you happened to do all the work and your area in the end was negative, chances are at this step where I have it color-coded, see how I needed to do g of x minus f of x, because if we looked at our picture, we can see that the green graph was the one on the top and the blue graph was the one on the bottom. So it's always the top graph minus the bottom graph in order to get that positive area in between. If you got that mixed up and you did the bottom graph minus the top graph, you will get the same area, it'll just be negative instead of positive. So if you find that answer in the end is negative, it most likely meant that in your setup you just did these functions in the wrong way. Instead of rewriting all your work, you could just sort of add absolute value bars all the way along, and that would mean the same thing. Okay. So the idea, to recap, what did we do? We first of all find where they intersect. Then do the definite integral between those two values and subtract the one function from the other function. So I want you to try these next two. So if you draw a picture of it, sketch it, if the two would intersect, since the parabola is going up, it would have to be that the line is on the top. Of course, if you screw up and you want to put extra absolute value bars around something, you can, just to be safe, but you wouldn't need these if you've done them. Well, if the parabola is going up, okay, and the line was underneath the parabola, then they wouldn't intersect. So the only way that they could intersect and create an area like this yellow part is if the line were on top. Otherwise, there wouldn't be any area between those. So when you figure out your intersection points by equating the two equations, and then when you put it into your area formula, you would have the line first minus the other equation. And then working through it, plugging in your values. Should have gotten 125 over 6 units squared. The line would be on top. Solving, simplifying, solving your integral, plugging in the values, and you should get 32 over 3.